Good morning, everybody. We are starting, I believe this is Wednesday, and we're rocking and rolling already. Hey, today's going to be our first video, so I'm just going to go through this. The beauty about videos is that you can speed them up, slow them down, watch them over. They'll be kind of short to the point, and then a lot of examples. So you can see one example, you can see two or three. And quit whenever you feel ready. The answer or the book homework is at the end and it'll be posted. So without further ado, here we go. Of course, good morning. We have two things I want you to do today. And one is understand notation. Notation, language is such an art of mathematics. Russians, Canadians, Chileans, Ethiopians, we can all do mathematics together, but we all have to have the same language. So notation is very important. Today, your goal is to walk out of this class. If I give you 2 points, A and B, there's two things I want you to be able to find. I want you to be able to find the midpoint, and I also want you to find the distance from A to B. That's it. Maybe you've seen this already. Well, here we go. All right, ladies and gentlemen, that is a point. That's it. It's zero dimensional. That's kind of weird. We'll talk about dimensions as we go. A line is 1 dimension, a plane, a flat surface is 2 dimensions, and then, of course, we add a little height to that, and we get 3 dimensions, the world we live in. All right, so we have a point. We will always label a point with a capital letter. Now, in special circumstances, we can name it Paul or Steve or Becca, but most of the time it's going to be one letter, and that letter is going to be a capital letter. All right, that's easy. Here's some examples I found of some amazing points around. Yeah, I didn't think you'd like that, but you know, you got to try. It's early. It's early. All right. This, ladies and gentlemen, is what we call a line. Now, I know you're like rolling your eyes like, are you serious? But there's some subtle differences between our notation. So a line definitely is defined by any 2 points. Any 2 different points, there's only one line that go through those points. That's pretty cool. But when you draw something like that, make sure you have the arrows on both ends like that. So that would be a line. All right. The notation for a line is you do any of the 2 points, A, B. If there's a third point on that, you could use any of those 2. And then over the top, you put like a little symbol with 2 arrows, and that means the line AB. All right. Of course, I could have named this BA. Doesn't matter. Order is not important. Just to illustrate that point just a little bit more, here is a line. There are 3 letters on there. I could have called this line YS, line EY, Eric Young, old Rockies player, and SE. So, pretty simple. All right, kind of getting the groove. I love geometry. I can do this. All right, line segments. That's what we'll be talking about a lot today. Here is a live line segment. Notice that the line is drawn right here, but it ends. It does not go in either direction. So A and B are called endpoints, and that's pretty important. All right. Well, what's the symbol or the notation for a line segment versus a line by itself? Notice the top. It's also a drawn segment here, but no arrows. No arrows. And this is red, line segment AB. That means it starts at the endpoint and ends at the other endpoint. Once again, I am happy to write this line segment as BA. All right. Now, this is something, in many years of teaching geometry, I kind of assumed this, so I'm going to be very clear about this. The notation for the distance between points. So if I want to write that I want to talk about the distance from A to B, what I do is I just write AB, but nothing on top. So if you're walking along in the woods and you're like, oh, look at that, there's a notebook, and then you see A, B with nothing, you would read that as, oh, the distance from A to B. That's what's in this note. Okay, so please be careful. We have the line, we have the segment, and we have the distance. All right, seems subtle and easy because it is. All right, the idea of congruent. Now obviously if you're writing some stuff down, you can pause it and just write this down. Congruent is an idea that will be with us throughout the entire year, or in this case semester. We're putting a whole year in a semester. In geometry we have a lot of shapes. We have triangles and parallelograms, trapezoids. When two shapes are exactly the same, we say they are congruent. If you weren't in this class, you'd probably say, hey, they're the same. That's fine. That's awesome. But if you want to get paid a little bit more, you don't want to get minimum wage. You want to step it up. You use the language that goes along with that. And the language there is the word congruent. Go ahead and say it out loud. Congruent. Yeah, I know you just said it to your laptop. That's sweet. That means you are ready to rock and roll. All right. Just a quick example. I know there's a lot going on here. Let's talk about it. I have line segment AB and I have line segment CD. I am saying something. You'd want to be able to read this in English. That is not line segment. That's not line. That is the distance from A to B is equal, because it's a numerical value, to the distance C to D. All right. So if they're the same, then I can mark these the same. And the way I mark these is I have these little tick marks. And they indicate that anything with that one tick mark is going to be the same length. Okay. To get real formal, and this is something that we'll run into, but I thought why not just throw it in right now. Here, we're not saying the distance, we're saying the line segment and comparing it to the other line segment. We don't say shapes are equal, we say that they are congruent. So we have a new symbol. It looks like an equal sign with a little squiggly. So when we're comparing shapes, we say they're congruent. When we're comparing numerical values or lengths or measurements, we can say that they are equal. I know, it's like, what, really? Is that a difference? Yeah, I'm just starting it early so we can be consistent throughout the year. All right. I think we're good with triangles. You can look at that later. Okay, midpoint. So the idea here is a midpoint is exactly what you think it is. If you live here and your buddy lives here, there's a halfway point. All right. If you got this score and you got this score, the midpoint is called the average. So that's all there is to it. We would say that the length from AM is equal to the length MB. All right, so how do you find it? Well, so I'm going to give you coordinates. I'm not going to give you X, Y. I'm going to give you actual numbers. And the idea is, how do you use those numbers to find the coordinates of this point? Okay, well, it's pretty simple. The X coordinate is going to come from the average of this and this, and the Y coordinate is going to come from the average of this and this. So when I say average, people are like, yeah, I can think of the concept, but let's say I gave you, you got a quiz score of a 12 and your second quiz score was an 18. So what's your average? Well, your average is found by taking those and adding them and dividing by how many there are. So that's 30 over 2, which is 15. So your average is a 15, and that's what we call grades. Your grades are a bunch of average, all your grades put together, divide by how many there are, and you get your grade. So the midpoint is a simple formula. All you do is take the two X coordinates, divide by 2, and the two Y coordinates, divide by 2. And what you end up with is the coordinates of the midpoint. Bam! Are you kidding me? It's that easy. Yeah, so if your mind's kind of like floating a little bit, a few examples probably really help. Okay, I just repeated those notes. So at any time you want to pause and make sure you have it, you can. Let's try an example. So those are my two favorite points, 3, 8, and 7, 4. We could graph them and kind of look where it is, or we could just use the formula to tell us the coordinates of the midpoint. So let's do it. To find the midpoint, we take the average of the x's. So the x's here are 3 and 7. So that's what comes here. The y values are here and here. So that's what we put together here. And then we just slow ourselves down, do some addition. 3 plus 7 is 10. 8 plus 4 is 12. And if I can divide by 2 in my head, I will. That's 5 and that's 6. So the point 5, 6 is directly in the middle of points A and B. I have another example. This is where you fast forward if you're like, oh my gosh, I got this. Or you're like, yeah, one more. That's exactly what I need. Well, here's 2 points. Negative numbers seem to be a little bit more challenging. So let's just be very clear and cool and write our work down. We'll get it every time. The average of the x's. So I take that x and I average them. And then I take that y and average them. Negative 7 plus 4 is our good friend negative 3. 2 plus 10 is 12. And you can leave your answer like this. I'm fine with that. I think if you want to get paid more, if you want to be a little bit more proficient, you just take that as far as you can. I certainly would accept negative 3 halves and 6, because 12 divided by 2 is 6. And let's say you have a calculator and you've done this. Negative 1.5 is probably what your calculator is going to kick out. Those are both beautiful. That's it. That's how you find the midpoint. All right, we have one more thing to talk about, and that is the distance formula. All right, I'm going to rely on previous knowledge here. This is one of the most famous theorems of all time, and it has everything to do with a right triangle. Usually what people need is if I put A, B, and C down, people are starting to think about it a little bit. It rhymes with Pythagorean, and yes, it is the Pythagorean theorem. So the Pythagorean theorem, my good friends, is nothing more than a squared plus b squared equals c squared. Always. Has to be a right triangle. But what is a, b, and c? A is the length of this. B is the length of this, and c is the length of that. If it's a right angle, then that length squared plus that length squared will always equal the longest length squared. Fancy word for that longest length, and that is called the hypotenuse. The hypotenuse. All right. Well, we're going to use this idea to find the distance between 2 points, because my 2 points might be from here to here. What is the distance between those 2 points? And that distance is length c. So we'll see if that helps. Just a really quick refresh about using the Pythagorean theorem. Here I have this, I caught this live right triangle running around, and I measured this side and this side. It was 3 and 4. Let's go ahead and put some units on there, 3 centimeters and 4 centimeters. And we want to know how long x is. All right, so since that's the longest side, we can use 3 squared plus 4 squared equals x squared. And then we just have to slow ourselves down, do the math right. We're going to square both numbers, 9 and 16. We're going to add those, 25. Now to solve for x here, the whole game is to try to get x by itself. Sometimes there's a 2 in front of it. Sometimes you have to subtract 5. Well, in this case, we have to undo the square. And the way to undo the square is we take the square root. Take square root of both sides. Hey, when you take the square root, what that does is it undoes the square. So this cancels this, leaving me just x. Awesome. And whatever happens, happens over here. It just so happens the square root of 25 is 5. It's asking what times itself is equal to that number. And sometimes you'll know that because, man, you had a third grade teacher that made you do 17,000 multiplication problems. And sometimes you're like, trust your calculator here. That's fine. Use your calculator to type in the square root of 25. And if you get 5, you've done it right. So check that out. Make sure that I help you with your calculator. A lot of times people have a calculator and they think it's going to help them, but man, it's hard to work. All right. So ladies and gentlemen, let's figure this out. There's our picture. There's point A. That's where I live. There's my best buddy. Man, I know the coordinates of this point, x1, y1. I know the points of this point, x2, y2. What I'm looking for here is that distance. But Mr. Sayers, what is all this talk about a Pythagorean theorem? I don't see a right triangle here. So glad you came to watch this today. Check it out. This distance is the distance from x1 to x2. So how do you find this distance? You just take this x2 and you subtract x1. So that distance is going to be x2 minus x1. This minus this will equal that. Very cool. Now this distance, as you can see, is the same thing from here to here. So if we take y2 minus y1, we're going to get that length. And you're like, Mr. Sayers, are you kidding me? It's a right triangle. We got Pythagorean theorem. It looks a little weird. There's no a, b, and c anymore. But basically, we're going to say this squared plus this squared is equal to this squared. And that is what we're after. So, using our Pythagorean theorem, c squared equals a squared plus b squared, we're going to substitute in what we want. And that is, the c is now our length AB. The one side is x2 minus x1, and the other side is y2 minus y1. That's it. This is the Pythagorean theorem, but using distance formula in there. Our biggest problem is what we do in the math book is we take the square root of both sides to try to undo this square. And so we get this formula, and this is the formula you'll see in the book. But if I were you, I would remember that it comes from the Pythagorean theorem. A squared plus b squared equals c squared. Well, that's it. I'd like to keep it under 25 minutes, so I'm going to kind of do a few examples for you. This is just plug and chug. Yes, I could have given you the formula and said just plug numbers in and get the right answer. But for me, it's really important that you have some idea how this is brought about. All right, let's do one or two examples. My life would not be complete if I did not know the distance between point A and point B. Boy, God, I just woke up. I just need to figure this out. Do you need application? Oh, I will give you plenty of application with the distance formula. So trust me that this is a skill that you want. Just like knowing how to add or subtract. It's like, oh, really? Do I really need that? Yeah, you need it. And then you can apply it. Just like this is a little bit more advanced. Certainly worth it. So here is our x1, y1. Here is our x2, y2. Some people, when they first learn this, is that maybe they write this on top so they can reference that. So when you're learning a formula, sometimes it's a good idea just start out with the classic formula so that you are plugging it in as you go. My advice to you is to go slow here because a lot of people can plug and chug, but most people make the mistake in just subtraction. So I have the difference of x's. So for me, I know this is x2 and this is, but it never matters what order you put these in. You can start here and subtract this, or you can start here and subtract that. because the difference is always going to be the same and you're squaring it. So you'll notice that this says x2, but I really grabbed this. It's like, wait, Mr. Sayers, what? There's, okay. So maybe we do this. I'm going to make this x2, y2, and this x1, y1. Can you really do that? Yes, absolutely. As long as you just label it and then be consistent. So this is -4 and -1. So you see how I write -4 minus, and then in parentheses a -1. This is where people go wrong right here, so be careful. And then the difference of y's, 7 minus 8. That's easy. I like to deal with that negative. A minus is a positive. So instead of trying to do all this in my head, I just rewrite it. -4 plus 1 is -3. I'm keeping the parentheses. -1, obviously from 7 minus 8. -3 squared is +9. -1 squared is +1. This is equal to the square root of 10. Please feel free to leave your answer as the square root of 10. That is awesome. That is what we call exactly correct. But no, you're a calculator person. You got to have the decimals. Well, there's no way for you to write all the decimals, so you have to change your symbol to like a squiggly equal sign, which means, hey, it's pretty darn close to 3.16. I'll take either one. Please understand the difference. All right, at this stage, you have everything you need to do all the homework problems. I'm going to do one more example. Feel free to play along. Otherwise, you could fast forward. So here's the 2 points. Here's my formula. Here is the plug and chug. I have plugged in my x's, the 3 and the 8. I have plugged in my y's, the -10 and the -2. Okay. I spent some time with some students yesterday. 3 minus 8, that's where they're getting stuck. So a vertical number line is a great way to go. So 3 minus 8 means start at 3, +3. Minus means go down. So I go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And that gives me -5. So that's why that's -5. If I want to do -10 minus 2, the first thing I do is I start at -10, and then since it's -2, I go down 2, 1, 2, and I end up with -12. So that's where I got those numbers, just throwing that out. It turns out -5 squared is 25, -12 squared is 144. Add those, I get 169, which is an amazing number. But if I use a calculator, or thank goodness I had Mr. Hazemeyer at Tavelli Elementary, made us memorize the perfect squares up to 15. I know that 13 times 13 is 169. All right. Ladies and gentlemen, there is your homework. It is page 24 of your book. The book can be found on the online geometry, or I have posted a PDF of chapter 1 on Google Classroom. What I'm looking for is those problems. Notice there's 4 midpoints, 4 or 5. There are 4 distance, and there's one really fun one. That is not a lot. I'm happy to give you a couple hundred problems. So the key here is please show your work and kind of walk away going, I feel comfortable with that. If you need to do extra, yeah, I know you just rolled your eyes. Please feel free to do that, because my goal is to not wear you out, but to find that happy medium that gets you over the edge. Let's look at some sample problems. Here's number 16. This is one off your homework, actually. This is not going to work. I can't read it. It may or may not be the right answer. You're not going to get any credit for something like that. If you do this, plug them in, add them, get the answer. Yeah, I'm happy to give you 1,000 points for that. That's awesome. Some of you can do a lot of this in your head. Please show me one step at least. Do not do this. If you just give me the answer, that's just not going to work. I know. Or explain. I can't do this slower. This is one-step problem for me. Communicate to me that you got it. One step usually does that. All right. When you are done, you're going to scan your homework or take a picture. You're going to hold on to that, and we're going to do that all together the next day. So you're going to have it ready to go, but I want to walk through that, that whole idea. So your goal is to, for Thursday, come in with your homework done. Okay. Good luck. Thank you. Talk at you later.